hand rim. 6 of these 1 centimeter spacers can be removed later to adjust the chair's overall width if necessary. The spacers on the hand rim align with the brackets on the wheel. Workers join them with industrial strength 4 centimeter steel screws. Replacing a wheel and hand rim like this costs more than $100. You buy replacement parts much like you do car parts through specialized dealerships. Bearings make the wheels roll with ease. Installing them is a delicate operation. Workers use special custom tooling to insert the bearings with extreme precision. The tires are rigid and have no treads because they're designed for smooth indoor surfaces. An aluminum cross frame is what enables the chair to fold. They assemble it with 6 or 7 screws per side, depending on the depth needed for the seat, which they'll install later on. The front part of the wheelchair is called the front frame. Workers lubricate the parts so they'll be easier to install. This also enables the wheelchair to fold with ease. They install the rear frame of the wheelchair, then make sure the cross frame folds correctly. Workers test the height adjustment lever for the armrest. Then they install a removable aluminum footrest, setting it to the desired length. It has a heel loop to prevent the user's foot from slipping off. The chair has a foldable sling seat. It's made of nylon and attaches to the frame with 6 screws on both sides. You can adjust the armrest height from 20 to 28 centimeters and the tension in the backrest with 3 Velcro straps. The backrest is made of nylon and comes in 9 different heights. Workers insert the wheel axle into the frame, adjusting it to fit with the optional features of the chair, such as a particular style of armrest. The axle has a quick release so you can remove the wheel in seconds. This plastic and aluminum hand lever is a parking brake. It keeps the chair still when transferring to a bed or toilet. This motorized chair has an electrical controller. The user commands it with a joystick. The chair runs on 2 12-volt batteries that power up in 8 hours from a household socket. Workers squeeze the inner tube into the rear wheel rim. The air valve slips through and the front and back parts attach with screws. Now the rear wheel can go onto the motor. They attach the seat and the joystick box, which has on-off and speed control switches. The battery pack provides 85 amps an hour. That's enough power for 16 hours or 40 kilometers. The batteries connect to the charger and controller to power up the wheelchair. A steel bumper and plastic rear hood called the shroud protect the back of the wheelchair from the elements and against minor collisions. This motorized model can glide at a leisurely pace or zoom around at a top speed of 12 kilometers an hour. The transverse flute has been an orchestral instrument since the 1700s. You play it in a horizontal position, blowing across an oval hole in the mouthpiece. The air hits a sharp edge inside, producing sound. You turn that sound into notes by pressing the keys that open and close the flute's holes. They begin production by inserting a solid steel bar into a sterling silver tube. Then, using a press, they lengthen it and taper it, reducing the diameter to 1.7 centimeters. This tube is part of what's called the head joint, one of 3 sections that make up the flute. The other sections are the center joint and the foot joint. Next, on another machine, they insert a second tube for the center joint. This device drills small holes to mark the position of each tone hole, the raised rim around each of the flute's holes. Now they insert titanium washers, called spiders, in the holes to help position the tone holes. They place a tone hole around each spider, securing it temporarily with copper wire. Once they solder the tone hole, they'll remove the spider. They solder little posts onto 3 strips of metal called ribs. The ribs and posts will later hold the flute's keys in place. Next, they use what's called a profile cutter to shave the tone holes by minute amounts to perfect the flute's sound. Now, using a wax injector and rubber molds, they create wax duplicates of the 120 different parts that make up the flute's 20 keys. Now they build what's called a tree. Using tweezers and a heated pen, they fuse the wax duplicates to a wax trunk that's 17 to 25 centimeters tall, depending on the type of flute. Then they place the tree in a perforated steel flask covered in masking tape. They pour in a liter of plaster, which hardens around the tree. Then they remove the tape and heat the flask. The wax melts through the holes, leaving plaster cavities in the shape of the key parts. The keys are made from tiny particles of silver or gold. These ones have a reddish hue because of their high copper content. The craftsmen pour a carefully measured amount into the casting machine's upper chamber. The machine heats the metal for 12 minutes. The plaster flask goes into the casting machine's lower chamber. They release molten metal into the cavities. Once the metal cools, they shatter the plaster under cold water, exposing a tree of silver key parts. Using a pneumatic cutter, craftsmen snip off the key parts. They have a dull finish because the silver isn't yet polished. Now they solder the key parts together and polish each finished key with a soft rotating brush. They also solder on a riser, which attaches the mouthpiece's lip plate to the head joint tube. They cut away excess metal from the opening of the lip plate. Then they use a lathe to cut out a hole in the head joint tube. A template ensures they position the hole correctly.